A message arrives from a trusted address with familiar branding, clean links, and the right tone. Nothing looks wrong until the investigation begins. Welcome to Wandt Quick Take, an AI-narrated educational video series exploring important topics in artificial intelligence, cybersecurity, and technology. Each episode draws from source materials connected to Professor Adam Scott Wandt of John Jay College of Criminal Justice, including lectures, notes, research, recordings, and earlier works. The series is designed for public education and provides a cinematic overview of those materials. This episode was assembled using artificial intelligence. The final narration and presentation may not always fully reflect Professor Wandt's precise views, wording, or intent. We used to think of phishing as poorly written emails with strange attachments. Today, the most dangerous attacks use correct branding, accurate context, and realistic business timing to seamlessly blend into normal workflows. The FBI closely tracks business email compromise, or BEC. Attackers target people involved in transferring funds by taking over legitimate vendor accounts to send invoices with urgent, expected deadlines. Professionals are targeted because they have access, authority, and predictable routines. When a deadline looms, they instinctively trust familiar names. Common advice reduces defense to telling users to carefully check the URL, but busy people multitask. A secure organization expects human error and builds a system around it. Advanced defense approaches this as an engineering problem. It requires a layered, failure-tolerant architecture designed to absorb a mistake without allowing a full system compromise. This diagram illustrates the first protective perimeter. We rely on 3 specific email authentication protocols to filter incoming messages before they ever reach an inbox. First, SPF authorizes which servers are permitted to send mail for a specific domain. Then, DKIM adds a cryptographic signature to help verify the message's structural integrity. Finally, DMARC lets the domain owner set rules for handling unauthenticated mail. But there is a catch. DMARC proves a domain identity, but it cannot guarantee the content is safe. A legitimate vendor account can be hijacked and used to send authenticated but fraudulent messages. Because an attacker can slip a scam through a technically valid email, perimeter filtering is incomplete. Defenders must build a second layer around the user's actual identity. Standard multi-factor authentication improves security, but attackers can bypass one-time SMS codes or bombard a user with push notifications until they approve a login out of sheer fatigue. To counter this, the National Institute of Standards and Technology defines a stricter standard, phishing-resistant MFA. Here, we see how protocols like FIDO and WebAuthn operate. Your physical device or passkey holds a private key. When you log in, it signs and transmits a unique public key to the legitimate server. If a human is tricked into entering a password into a perfect replica of a login page, the hardware authenticator checks the domain parameters. When they do not match, the device physically refuses to output a valid signature. The imposter site gets nothing. The burden of trust shifts away from the human eye trying to spot a deceptive link, relying instead on cryptographic math that cannot be socially engineered. However, technology alone cannot stop every attack. Sophisticated threat actors will call a help desk directly, spoof a voice, or compromise a partner organization to bypass digital perimeters entirely. High-risk actions like wire transfers or password resets require procedural friction. This means implementing an independent, out-of-band verification process before an action is finalized. Separating the payment action from the email request breaks the attacker's momentum. If a vendor emails a change in routing numbers, the payment pauses until it is verified through a known, trusted phone number. This completes the failure-tolerant architecture. Email filters catch the obvious noise, cryptographic identity stops unauthorized access, and procedural friction stops financial fraud. The human element still matters, but training should be practical rehearsal for these specific threats, not a theatrical, shame-based compliance exercise. Eventually, a user will click a malicious link. Fast, unpunished reporting is often the deciding factor between a contained incident and a severe breach. When a mistake happens, rapid incident response takes over. Defenders preserve headers, review sign-in logs, check MFA registrations, and immediately revoke active sessions to contain the threat. Advanced phishing defense measures success not by whether every employee spots every deception, but by whether the organization can absorb a mistake without losing control of its systems. Professionals must slow down when a message asks for money, credentials, or urgency. Rely on systems to verify trust, rather than instincts alone. Like, follow, and subscribe for more deep dives into emerging technology, digital investigations, and the ideas shaping our future. And remember, stay curious and want knowledge.